Guys, welcome to another home lab video here today. In today's video, we'll be continuing our Kubernetes stuff. So essentially, if you haven't seen, I actually built a Kubernetes cluster in my home lab. A lot of fun, a lot of work, a lot of staring and going, what the am I doing here? But at the end of the day, we got it working and it's pretty good. Now, there are some downsides, obviously, where you have to like provision storage manually, and you don't really have routing if you just leave it with a metal LB load balances. So in this video, we'll be focusing on the storage, and then probably the next video, we'll be focusing on the routing using like traffic or something. But for storage, what I decided was one of my friends' recommendation was to use Longhorn. So essentially, Longhorn is kind of auto provision and set up your volumes whenever there is a persistent volume claim from project or whatever you're setting up, which is great because then you don't have to manually create it. You don't have to worry about like permissions like how I set it up with Uptime Kuma in my last video, where you essentially create a volume, put it on a mount path. And if you're running like certain services, you might have to change like the ID and all that stuff. So it's actually kind of like a lot more work, especially if it's not working. So we're going to go with Longhorn, and we're going to show you how you can set it up and use it. So let's get started. All right. So the first thing to do, and I've actually had a few of this already set up beforehand. So on every single node, what you want to do is install the iSCSI initiator. Did I spell it right? No, I didn't. That doesn't look right. There's not enough I's. Initiator utils. There you go. And I've already installed this on all of them. So the iSCSI is essentially what the Longhorn will be using on the backend to kind of do like the disk related functionalities. So you installed that on every single host. You'll also want to make sure that it's started. So you want to do systemctl start iSCSID. So you want to start it, which I've already started it, so it's already started, and then enable it to make sure it just starts on boot. If you ever reboot the machine, and that's pretty much what you'll need to do for every single host. After that, you're pretty much done on the other nodes. You can just focus on your kube master and where you're going to start doing the deployment. So what we'll do is create a namespace. So kubectl create namespace, and we'll name it Longhorn. Now I'm going to get an error here because that already exists because I already created it. But you'll want to create it. You can name it obviously whatever you want for your namespace, but that's what we'll do. Then we'll use Helm. So if you don't have Helm installed, you can either check out my previous video, but if you look in my GitHub README for this video, you'll also see, I'll put in a little bit of like, this is how you install Helm because it's like 2 lines to install it. And we'll add the Longhorn repo on https charts.longhorn.io. And again, it says it already exists, so we're going to be skipping that. And then what we'll do here is we will pull down the Longhorn configuration. So Longhorn, and then we'll untar it. So this will essentially pull it down, and we can cd to Longhorn here. And we can see that there are, your charts, your templates, your values. And in this case, we will actually edit a few things. So we'll need to edit the values in regards to defaultReplicaCount. And the reason why we have to update this is because we're only running 2 nodes. The most number of replicas that we can have for a volume is 2, because I only have 2 nodes and each of them have 1 disk, so I can't create 3 replicas, which is the default here. So we'll want to update this to be 2. Now, in your case, it depends. If you have, 3 nodes and you're like, hey, I want 3 replicas for any new volume that's created, you can just leave it as default. But if you're like, hey, I don't really need like so many replicas, I just need like 1, you can change it to 1, or you can do it 2. And obviously, if you had 100 nodes, you probably don't want 100 replicas unless you're trying to be like AWS with like 7 nines, 99%, thing and whatnot. But in this case, 2 is going to be sufficient for what I'm doing. So then we'll save that. And then what we'll need to do is also update it so that the service is accessible via my Metal AB load balancer, which I will change eventually to traffic in my next video. But in this case, we still want to be able to access the GUI without being able to use traffic, and we only have Metal LB. So we will actually edit the service after it gets created. So we will actually just do a home install Longhorn and then dot for specifying the specific directory of what it'll pull, and then we'll put it in the namespace Longhorn. So then this will essentially deploy Longhorn into your cluster, so you can do like a kubectl get pods n -n for namespace and then Longhorn. And you can see that things are running and initializing here. So this will take a few seconds because like there'll be more things that pop up and get created. But while that's doing, what we want to do, kubectl get svc for service and then Longhorn for the name. We'll want to see that we need the Longhorn front end accessible, because right now it's not accessible via any external IP because it's just via the cluster. So we will use essentially Metal LB. So like if I were to just look at all my services, right? We can see that right now my uptime Kuma is using 194 in regards to what we have allocated, which I said it was like 194 to like 196. So we'll just do 195 as the next one, and I will make that big again. So what we'll actually do, and I actually have it typed out in here, so I'm just going to copy and paste. But we'll essentially patch the service, which is essentially just editing the service, and we will merge in the spec for the type to be a load balancer and the load balancer IP being the next IP in the list, because you can't use the same IP. Metal LB won't let you use the same IP, so you can't have the same IP even if it's on different ports. So now we can do kubectl gets svc and Longhorn, and we can see that I should be able to now access this on 195 on port 80. So I'm looking forward to getting traffic set up and showing you guys that, because then I'll have HTTPS also set up. But in this case, I don't. So we'll have to do 195, and we can see that the dashboard is allocated. So I'm assuming most of it is probably working now at this point, because it looks like most of it is responding. So let's just do kubectl get pods and Longhorn. We can see everything looks to be running and ready. So yeah, I mean, everything's up, ready, working, which is great. And that's what you like to see when you're setting things up. And honestly, that was not the case when I did this the first few times. So but anywho, so now you got a nice graphical user interface for your volumes that you can use. You don't have to use the kubectl get PV, kubectl get PVC, try to map things together, make existing claims, put in values. It's a lot of work. It's a lot of work. This will simplify it. So you can see here that we have no volumes because none were created. So we'll probably end up, I don't know what example I'm going to do yet. We might use uptime Kuma. We might do something else. But what we'll do here is go to nodes, and you can see that we have the two nodes, my node 1 and node 2. You can see that in here, it will auto default make your file system because it'll mount the path var lib Longhorn and make that accessible. What you'll actually want to do is unschedule that, in my opinion, because you don't want data to actually be able to live in your volume that you would boot or you do things on, right? So we're going to actually disable that on both so that it won't use those, because you don't want those to fill out. Then now that they're both disabled, we can add a disk. So in this case, what we'll do is add a new disk. We'll call it disk 1, and the mount path is mount disk 1. We'll enable scheduling, and then we won't do any storage reserved. So storage reserved is also confused me at the time, because I was like, wait, what am I supposed to put here? Am I supposed to put what the max is? This is how much you want to have people not use, right? So it's reserved, so they won't be able to use it. But in this case, this whole disk is meant to be used, so I'm going to put it 0, right? So we can hit save here, and then it will do its checks and schedule it, or make it schedulable once it's validates. But what I essentially did on each of my nodes was in Proxmox, I added a new disk. Then I created a physical volume and then a logical volume that's mounted to mount disk 1. So mount disk 1 was actually created manually by me. So we can see if we did dfh grep disk 1, you can see that this volume, this file path is just my logical volume that I created, and it's 50 gigs essentially. If you're interested on how to do like volume manipulation in Linux, I would probably recommend checking out my like Yum server, because I like go through and create like a whole, volume group, volume, how to extend and everything. So that's probably the best video to look at. But I did it for both Kube Node 1 and Kube Node 2 in this case. So you can see here now it's available. It's 49.9 close enough to 50. It's practically 50. So we'll do that for Node 2 as well. Add a disk. And then we'll still name it disk 1 essentially, because it's still disk 1. We can name it. It doesn't really make a difference, but that's what we're doing. And then enable scheduling, hit save. And then that should finish itself too. So that's pretty much it for like this setup. Obviously you can add more disks in the future if you need to, or do things, but what we want to do now is essentially get a volume created, and we'll use Uptime Kuma probably here. So let's try it out with Uptime Kuma. So we'll essentially delete our Uptime Kuma instance and then recreate it. All right, so what we'll do here is actually we need to go back to our storage, and let's update our storage class. So we will actually set our NFS storage class to not be default anymore. We'll set it back to false. So essentially it'll force it to use the other one, because now we can do kubectl get storage class, and we can see that the Longhorn one is default now. So like we don't need 2 default ones. So let's do kubectl apply f storage class. And then now we can do this, and we can see that the NFS storage is not default anymore. So now we won't have any confusions in which one can be used as default. But you don't need to worry about that unless you follow my like first video and you did the exact same thing. So in here, what we can do, and I'm trying to think about the best way of doing this, is by values, storage. Okay, so I didn't use an existing claim. I essentially just let it create. So what we can do is actually do like a home uninstall uptime and uptime. So this essentially uninstalls uptime completely. So then we could do kubectl delete uptime volume. So this will delete any existing volumes that we created personally, because we don't need them anymore. And we're going to just let it auto create. So we'll just do and uptime. And then I think that's pretty much it. So kubectl get pods and uptime, which should show nothing. So now we can do a home install uptime dot and uptime. So this will reinstall Uptime Kuma. Now, before I should know, don't delete your Uptime Kuma instance and the volume associated with it if you actually like set it up and actually want to migrate the data. This, if you delete it, you're gonna delete everything. So once you delete the volume, anything that would have been saved isn't saved anymore. Because this is my test instance, I didn't have to worry about that. But if you're doing this in your production instance, please don't just delete your volume, actually like save it and get the data out and then migrate to your new instance. But if it's just a new instance, you can blow it away like this, obviously. So then we'll reinstall uptime. So in here, we should be able to do kubectl get pods and uptime. We can see that this is in pending status. And then we'll do kubectl get pvc and uptime. So we'll see that there is an uptime in here. It actually it got the Longhorn storage class. kubectl get pv, which doesn't seem to show up anything, but I think it should show up stuff. So, okay, I'm gonna have to do this real quick. Okay, so what's the error code? Unable to create volume and mission webhook validator. All right, so based off of the error, I believe I need to create a backup target, which I think would have been created by default because I didn't have to do this on my other on my actual instance, but I had to delete this instance, and I might have deleted too many things and then recreated it. So in this case, if you do run into that error, you can create backup instance. We'll name it default, and I think you can just leave everything else as all right, and then I think that's fine. I think that's all you need to do. It says status error. What's my Longhorn say? Oh, mine says status error. I think it just needs to exist. I think it just needs to exist. So I'm gonna force it. So I'm gonna do home uninstall uptime. I'm just gonna force it to kind of delete and then recreate essentially. Dot. There we go. kubectl get pvc and uptime. Okay, yeah. So I don't know if that was something that I did in regards to when I was trying to clean it up from a bad install earlier. But if you do run into that error, you can just create the backup target. So you can see now that the volume claim is there, and then you can see kubectl get pv. You can see that the volume's also there, which is great because now you don't have to do anything about it. And you can see in the GUI in here that if you hit volumes, you can click on it, and then you can see that it is essentially here. I have 2 healthy nodes and apparently 1 that's not healthy. And I have no idea about this stopped one here, because that I don't think means anything. I don't know what the stop one is because I don't have additional stuff. So I'm gonna go delete that. I think that might have been a glitch. So we'll delete this. Yeah, we'll delete that replica. Pre-check new replica failed, but I only wanted 2 replicas anyways. Yeah, default replica count 2. So why is this in a degraded state? Options. Oh. Oh, some odd reason that still took 3 for the replica count. Don't know why. Even though I have it set at 2. So that makes more sense. It would have definitely failed on 3. So in other words, my install might have not been perfect, guys. But it should still work. It should still work. But now you can see it's healthy. So if you actually have the replica counts 2 and it auto created as 2, you'll see that this is actually created, and now you should see uptime kuma kubectl get pods, and uptime. You can see it is running now successfully as well. You could actually just do get svc uptime. See, I would have to reapply the metal lb thing. I'm too lazy too though. But it does work. It does work. You take my word for that one. So if it keeps on doing 3, you might need to double check. There might be another setting, but I only changed that one on my other one too. So default replica count 2. Maybe I just need to hit save again. It's weird. Sometimes that's weird. But that's how you essentially set up Longhorn, guys. We did run into a few issues, but that's kind of, honestly, in my opinion, that was a lot less than when I first initially tried this. But now, in the future, whenever something gets created, essentially, it will just auto provision the volumes in here, and you can actually do a lot of things. So like you can take snapshots, you can create backups if your default target was correct again, and then just essentially work for all your volume creations, so you don't have to create it manually or manage them via the command line with kubectl. So probably in the next video we'll be doing traffic, because I am so ready to have HTTPS and DNS links instead of IPs, guys. So that's probably going to be the next video on how to set up traffic with a self-signed cert on Kubernetes. So stay tuned. But if you did enjoy this video, please leave a like, comment, and subscribe, and we'll see you guys in the next video. Bye.